Our next module that we're going to look at is called high throughput computing. So this is a little bit different than what we've been looking at so far, which would more regularly be called high performance computing, or HPC. So let's see what HTC, high throughput computing, is all about. So what is it? What is high throughput computing? Well, HTC means getting lots of things done per time unit. So in other words, making 1,000 different jobs run over the span of a couple weeks, or 100 jobs in a day, or something like that. So it's based on jobs or complete programs, whereas high PC or HPC, high performance computing, is all about getting one particular job done in less time. Okay, so it's more about calculations per second in HPC, whereas in HTC we're thinking about jobs per unit time frame. So throughput is sort of measured in terms of when do I submit it, when does it finish, whereas performance is just the number of calculations per second while it's running, or the number of overall time it takes when it first starts. So for example, let's say I submit something right away on January 1st of a new year at 1 o'clock a.m. And it sits in the queue for a while because the cluster, for whatever reason, is really busy on January 1st. I don't know, maybe everyone's trying to take advantage. And then it finally starts running at 5 o'clock p.m. on January 2nd, but finishes running at 6 o'clock p.m. on the 2nd. So then we would say, relatively speaking, assuming this is a really huge job, it's got fast performance, or good performance, because it only took an hour to run, but its throughput is really slow or low because I'm only getting one job done in a day and a half. Okay, so our Wikipedia definition says that HTC is the use of many computing resources over long periods of time to accomplish some task. And often that task is like a lot of little tasks or smaller tasks. Okay, so it's organized as lots of smaller jobs that have minimal or no communications between them. So in HPC, we might have a lot of synchronization going on between processes to keep them all in step as they go. In HTC only works really if those jobs don't have to talk to each other as much as possible. So HTC really lends itself to things that are embarrassingly parallel. Remember, embarrassingly parallel things are problems that don't require communications between the different parallelized parts. And often these jobs are scheduled opportunistically. So they're set up to run when the compute resources would otherwise be idle. So the scheduler for HTC sort of looks for idle time on resources and executes the jobs when those processes are idle. So here's an example. This is a real example from here at Doane. Suppose we have all of these individual images of maize seedlings, and what we're trying to do is to measure with a computer the size of the roots. Okay, so let's suppose there are thousands maybe of, or hundreds of thousands of those images that need to be processed. So we could write non-parallel code to process one image and output the desired result. So the idea is that this program would take one picture, do the processing, output the result. And then we would utilize an HTC scheduler to distribute that all over the place, one image, the program, per compute node, and then maybe just scatter that all over, like the Open Science Grid, for instance, is an example of this. We might have thousands of those things out there, and they run whenever they're scheduled to run, but overall, per unit time, we get a lot of work done. Okay? So our next video, then, we're going to talk about opportunistic computing and then get into our first example of a Monte Carlo method.